On behalf of the Australasian Centre for Rail Innovation, I'd like to call this Budget Estimates hearing into session. I'm the Honourable Senator Julie Bishop, representing the Estimates Committee, interviewing the University of Newcastle's ACRI research team. This session is being conducted with the intent to elicit a justification for the fiscal expense incurred by this UON research unit.
I'll take this one, thanks Julie. The majority of the funding was put towards constructing a viable test rig upon which various sensor equipment for this project could be mounted.
And this test rig, as you describe it, what was its purpose and what equipment exactly did you mount to it?
Well, as you know, Julie, the purpose of this project was to create a semi-autonomous trackside robot capable of performing simultaneous localisation and mapping, standalone localisation and change detection, object tracking and high-resolution photogrammetry in the rail corridor, with a view of keeping workers out of harm's way, of course.
Yes, I understand that, Mr. Harvey. We are all familiar with your brief, but if I could call you back to the question, what exactly did you spend the money on?
Well, we made a test rig, Julie. All-terrain cart, LiDAR, a camera and a GPS. And I think the results speak for themselves. Could we play table item number 3, please? Here we can see the system performing simultaneous localisation and mapping in real time at the University of Newcastle's engineering precinct. The system is collecting data from the LiDAR, camera and inertial measurement unit to construct a detailed map of the outdoor environment. Clearly these results show promise for future applications of the project and justify the expenses incurred over project development.
That is very impressive, but I'd like to inquire particularly about the expenses.
Yes, of course, Julie, but to really understand the expenses, you've got to comprehend the capabilities of this robot. We're trying to localise here, Julie.
And what is that?
Well, do you know where you are, Julie?
The process of localization involves identifying a robot's position within a known map. In this case, it was found that using iterative closest point scan matching to align a LiDAR scan with a map constructed by the SLAM solution achieved the best results. Specifically, KISS ICP was found to be the most robust and accurate solution available. Additionally, the system should detect changes in the mapped environment. Using data from the scan matching process, we were able to identify a person in the scene here.
Again, very impressive. But where did the money go? You had $250,000 and I would like to ascertain what you did with it.
Well, to understand the expenses incurred, you've got to understand the complex nature of software development. We're trying to run a neural net here, Julie.
A what, sorry?
Here you can see the 3D environment and 2 people walking through it. We can extract the measurements corresponding to the people by using a neural network to extract the points associated to an object of interest. This allows us to predict their trajectories when they are blocked from view by the environment. We can then also remove the people from the point cloud to provide only the background environment to Jasper's mapping algorithm.
So that's where the money went, is it?
Well, we never said that, Julie. Certainly a percentage was spent there.
What percentage?
A percentage of the funding, Julie.
Well, you have to understand, we're trying to reconstruct objects here, Julie.
I thought you were running a neural net.
We are, Julie.
But you're also trying to reconstruct objects.
Of course, Julie. These things go hand in hand.
Photogrammetry allows you to take a series of images and transform them into a 3D model of the object or scene that is featured within those images. For instance, this series of images of a random 3D printed shape were able to be transformed into this 3D model, using many different concepts including feature extraction, feature matching, structure from motion with a focus on triangulation, and dense image matching. This area provides an avenue for conducting remote inspections of the railway tracks, which would see improvements to safety and reliability by removing people from this hazardous environment.
So is that how the money was spent?
Partly, Julie.
Okay, I've had enough of this juvenile question judging. I'm going to need an itemised list of how all this funding was spent, or you won't be receiving any more from us.
Well, you only had to ask, Julie.